So hello everyone, in this video I'm going to show you another template which is available on SmowCode, which is the I2C template. And as you can see, I have the I2C template opened here on my screen. I2C protocol is a very commonly used protocol in all industrial systems, and these are one of the most commonly used nodes, as they are the core nodes for the I2C protocol. So what is I2C protocol and how does it work? The I2C protocol works with two wires, mainly SCL and SDA. So the SCL is the clock and the SDA is the data, which the wire which carries the data. So each clock cycle a bit is sent to the sensor or the device which is connected through I2C protocol, and in this flow we'll see how we do that. So to start off with, we have the on start node at the start, and then we have the display node which says creating array for wake up data. Then we create an empty array, and then naming it wake up data. As you can see, the output is wake up underscore data. Then we have our first element of the array, which adds register address 0x6b to the array, which is the power management register. And the second value in the array would be the value 0x00 to wake up the register, which wake up the sensor, which is the disabled sleep mode value. And then we display I2C port auto initialized in background, which is a info message for the user. And then we display writing data to I2C port, which is once again a log message for the user. Then we write the wake up data to address 0x68, which is the MPU6050's I2C address. If you go to the I2C write and its properties, you will see that you have the I2C port config at the start, where you choose the I2C port. I have chosen I2C0 for our ESP32. Then we have the SDA pin and SCL pin, which we can set, and in the advanced settings you can pull up enable on for the SDA or pull up enable on for the SCL, and change the frequency as well. I'm going to keep it as it is. Then we choose the address of the target I2C device. We are using an MPU6050 which has 0x68 as its address, so we have chosen that. Then you choose whether you want to read or write from this to the sensor or from the sensor, and we're going to write the data, the wake up data to it, so I have chosen write. So this is going to write the wake up data to address 0x68, which is the MPU6050 we are using to wake up the sensor. Then we are going to create another empty array, and we are going to name it who am I register, and then we are going to fill the register address 0x75, and then we are going to write it to the sensor to prepare read from the address 0x75. So as you can see, everything is the same. The data we are sending is going to be 0x75, which is our new array, and then we display reading data from I2C port, and then we use the I2C read to read the data from the given address. So you have the address right here, we read it, and we set the receive length as well, which is the number of bytes the master expects to receive from the slave during an I2C read operation. So we expect to receive 1 byte, and it displays the return device ID, which is what the who am I register does. Then we have our second flow, which is a repeating flow every 1 second. So it toggles a pin high and low, which is basically a blinky, and then it displays creating array for accelerometer to register data, which is info message for the user. We once again create an empty array, and we name it accel read register, and then we have 0x3b, which puts x-axis high byte register address to the array for our MPU6050. Then we write data to the I2C port once again, which is once again a debug message for the user, and we write the write to start reading from Accel X register. So we write 0x68 to the address 0x68. We write the data Accel read register, which starts reading from accelerometer axis register, and once again we read from it, and we can see that we read from the same address, which is our MPU6050 sensor, and this time the receive length is 6. Then we set the received data, we manipulate it to display it on our serial monitor. So all of this is basically manipulating the data, and then we get the actual accelerometer x-axis data, and that's what we display here in the end. So if you don't want to do all of this, we also have the MPU6050 node already present on SmowCode, which lets you not do the hassle by calling I2C write and read again and again. So if you use the MPU6050 read, you can directly get the accelerometer X without doing all these calculations. So let's upload the code to our ESP32, and I'll show you the circuit and serial monitor in just a moment. So here is our circuit. As you can see, the leftmost wire, which is the VCC wire, is connected to the 3.3 volts on our ESP32. The next, which is the brown wire, is connected to ground, and then we have the SCL, which is connected to pin 22, and then the SDA, which is connected to pin 21. I have already flashed the code on our ESP32. Let's connect the serial monitor and see the value. So I'm just gonna refresh it, and as you can see, we can see that it starts with creating array for wake up data. It wakes up our sensor. The I2C port is auto initialized in background as expected. Then we write data to the I2C port, and we get the the device's ID returned, which is whoami104. So 104 is the ID of the device, and as you can see, it reads the axle x's value, so it's minus 0.148 for now. If I move the sensor, as you can see, the values slowly change if I move it slowly, and this confirms that this is a real-time data, and this is how you use the I2C nodes on SmowCode.